Hi, my name's Steve Briley and I'm a Senior Lecturer at Sheffield Hallam University. I'm giving you this presentation on normalisation, which is being billed as a revision lecture because I'm going to go through it fairly quickly. So why do we normalise? Why do we go through this process, which we call normalisation? Well, firstly, it's to eliminate duplication of data items. That's a big problem in databases, particularly the flat files that we're often associated with Microsoft Access. To avoid problems with inserting data, updating data and deleting data, also a major problem in databases. If you don't have a normalised database, then you'll have to insert many rows of data to achieve the end result. And thirdly, it's to simplify the table structures. And fourthly, normalisation is a mostly technical exercise which only demands that you follow the rules. So where do we start? Well, we've got to select suitable inputs or outputs to or from the system for normalisation. These are normally forms or documents if the system is a manual one, which you have got from the interviews with the key members of staff. If it's a computerised system being re-engineered, then there can be normally screens or reports. Secondly, you've got to discard any inputs or outputs which are duplicates or subsets of others. You will often find the same entity appearing on different forms. So normalisation step one. Well, firstly, we've got to represent the data in unnormalised form. And this is you take the screen or report and you list all the data items in that screen or report in a column on a piece of paper. You don't do anything else. So here we have an employee training record, which the data items are employee number, the name of the person, national insurance number, the department number, department name, the course code and the course title. And then we have to select a primary key for this data. The primary key is selected to make every instance of the data unique, and it should be relevant to the form being normalised. So in this example, we're choosing employee number. We could have chosen department number, but that isn't relevant to the form being normalised. Step two is to remove repeating groups of data. This is called moving to first normal form. A repeating group is any attribute or group of attributes that has several values for a single value of the primary key. And we denote it by putting a bar down the side of the data. So in this case, we have an employee number as the primary key, and the repeating data is course code and course title. We put a bar down the side of that and to denote the repeating group. Next stage is to remove the repeating data and place it in a new table along with a copy of the primary key of the unnormalised form table. So we take the repeating data, which is course code and course title, and we move it across into a new table and put the employee number as the primary key of that table. Now we have two tables with the same primary key, and that is not allowed in Relational Database Design. So what do? We create a new primary key for the second table using the primary key of the first table, which is employee number, plus one or more additional attributes to uniquely identify each row. So in this case, the second key, the composite key, is employee number and course code. Step three is to remove partial key dependencies, which is called moving to second normal form. Partial key dependencies are attributes which only depend upon part of a compound key. A key which is a key made up of more than one attribute. And in this case, we only have one compound key. That's the key in the second table. So the first table, the top table, moves across to second normal form unaltered. In this, we remove any attributes which are not dependent upon the whole key and place them in a new table along with a copy of the key attribute they are dependent on. So in this case, we have employee number, course code and course title. And what we have to do is to ask the question of each attribute in that table, is it dependent upon the whole key or just a partial key? So we say, is course title dependent upon employee number? And the answer to that question is no. Is course title dependent on course code? And the answer to that question is yes. So that is a partial key dependency. And we remove that to its own table and take the other table across with the attribute removed. So we have three tables now: employee number and course code, and course code. Step 4 is to remove non-key dependencies. So we remove any attributes which are not dependent upon the primary key of that table along with a copy of its true key. Most of the time we will be working here on the first table in the relationship. So we ask the question, is it dependent on the primary key? So we take name and we ask, is it dependent on employee number? And the answer is yes. We take department number and we say, is that dependent on employee number? And the answer is yes. We take national insurance number and we say, is that dependent upon the employee number? And the answer is yes to that question. We take department name and ask, is that dependent on employee number? And the answer to that question is no. So we remove that together with a copy of the key upon which it is dependent. And the key is department number. So we have four tables now: employee number, department number, employee number and course code, and course code. So we have the fully normalised tables now, and we have to name each third normal form table. So we name them employee, courses attended, department and course. These are the four tables in this database. Now we have to figure out the foreign key attributes. Definition is an attribute of an entity or table which is also the primary key of another. These foreign keys provide the links or relationships between the tables and entities and are identified with an asterisk. In effect, they are managing the relationships for us. So, department has many employees, and so department number becomes the foreign key in the employee table to link that to department. Employee number is a foreign key in courses attended to the employee table, and course code is a foreign key in the courses attended table to the course table. There are three relationships in this database. That means three foreign keys, one foreign key per relationship. So we have to build the final entity model. When all inputs and outputs have been normalised, all tables with exactly the same primary key are merged and given the same name. For example, two tables called course, both with the primary key of course code. In one table the attributes are name and trainer, in the other table the attributes are name and number of days. Those are merged together to form one table with the primary key of course code and the attributes of name, number of days and trainer. We draw an entity icon to represent each table and name it. So the employee table has an entity icon and those are the attributes that go in the employee table. We then add the names of any primary key and foreign key in that table. So in the employee table we add employee number as the primary key and department number as a foreign key, denoted by an asterisk. Now we join all the entities with common attributes together. So department is joined to employee because there is a common attribute. Employee is joined to courses attended because there is a common attribute. And courses attended is joined to course because there is a common attribute. And then we add the one-to-many relationships. And the many end of a relationship always goes towards the foreign key. A truism in database design is the crow's foot grabs the asterisk, and that is exactly what we do here. So, department has a one-to-many relationship with employee, Employee has a one-to-many relationship with courses attended, and course has a one-to-many relationship with courses attended. Easy.